What is up, YouTube? Let's take a look at the different security principles and what's involved in implementing security in API design. Let's get into it. With the popularity and usage of APIs growing exponentially each year, API exploitations have become a big focus area. An API doesn't function in isolation, but it's designed to be used with other applications. For example, Google's API communicates with Facebook's API to incorporate sign-in. An insecure API won't only lead to the vulnerability of our data, but also puts the sensitive data of other applications at risk. Implementing security protocols is a high priority in API design. We need application security on the client and server side, data security, REST and in transit, and network security. API security is a combination of these three. What if we have an API like Spotify which uses our Google account to log in? What are the procedures and protocols we should follow to make sure our sign-in information isn't intercepted or tampered with? Why do we even use Google to sign in? What level of information should be shared between the application to authenticate a user? We'll focus on the security aspects of API design being authentication, authorization, encryption, access control, etc., so we can protect data in our APIs. As time goes on, the number of digital attacks are increasing. There are numerous methods through which malicious users may attack, the primary methods being as follows. Distributed denial of service. This is when multiple machines target a specific entity in our system by overloading it with requests to disrupt its regular functioning. The attack traffic in this method is usually in the form of a botnet. Insufficient authentication. When our clients aren't adequately authenticated, the procedure through which our API verifies who the user is, our API may receive bogus or potential malicious calls that may hinder its functionality and lead to issues in access control. Injections. When malicious code is entered into our system, it endangers the data present in our API along with access control. This is most commonly done through cross-site scripting or SQL injections, which we'll expand on in an upcoming lesson. Exposed data in API calls. When transferring data, an attacker may intercept the data and impersonate one of the parties, which is known as the man-in-the-middle attack. This can lead to the impersonator gaining unauthorized access to our data, which could lead to devastating consequences. The diagram illustrates the surfaces where these attacks may occur from. There's no such thing as a perfectly secure API. Our APIs have to be scalable in order to implement new security mechanisms. So here we have insufficient authentication, which could be an area where we could be attacked from, or data exposed in an API call. The process of API security. It's much easier and resource effective to consider security at the inception of the API's design and scale it as time goes on, rather than retrofitting an already finished API later in its lifecycle. There are many aspects that should be contemplated when designing a secure API, namely the ones mentioned in the illustration. So we have assets. Every resource is an asset that we aim to protect. This may include databases, web servers, or user credentials. Security goals, defined as the objectives we aim to achieve in the context of security, typically modeled by the CIA triad. There's also threat modeling, which is an evaluation of the threats that we may encounter in a particular environment. We define the class of threats using the STRIDE acronym. There are also mechanisms. So these are the procedures applied that help us guard our API against the threats that we modeled prior. So we use encryption, authentication, authorization as our primary mechanisms. So let's talk about security goals. Our primary security goal should be the protection of these assets, most commonly defined through the CIA triad. The CIA triad is a general security model that has been employed for decades. This triad is represented by three components that lay the groundwork for our design principles and implementations. The three factors are as follows. Firstly being confidentiality. This refers to the guidelines and regulations administered that make sure that only authenticated users have access to relevant information. enabling secrecy and privacy serves as the primary goal of confidentiality. Integrity. This aspect ensures that the information present is accurate and reliable and not tampered with in any way, whether it be an intentional alteration by attackers or data corruption in transmission. There's also availability. This feature guarantees that users we have validated have a constant entry point to the data they wish to access. It refers to our servers, machines, and applications being in a constant state of functioning so our authorized users can access our resources in a convenient manner. What is a real-life example that highlights all three principles of the CIA triad? So for example, an ATM commonly displays all principles of the CIA triad. Its PIN code reflects confidentiality, its logging of all deposits and withdrawals preserves the integrity, and its machines being publicly accessible anywhere demonstrates its availability. Now let's talk about threat modeling. It's imperative that we define the threats faced by our API in the environment in which we run it. These attacks only increase as the usage of APIs become commonplace, leading many to speculate that API attacks may become the most relevant attack in the future. The set of threats relevant to our API is defined as our threat model, which can be classified through the STRIDE acronym. So looking at the STRIDE acronym, the first one is spoofing, which means impersonating a user, tampering, unauthorized users altering data, repudiation, the ability to deny that an action took place or that a communication occurred, information disclosure, leaking private information, denial of service, denying services to authorized users, elevation of privilege, obtaining unauthorized privileges. So the process of threat modeling is as follows. First, we curate a system diagram highlighting the primary entities, such as clients and endpoints in our API, and pinpoint the trust boundaries of each component. Then we identify the information flow between the system entities and model it as directed arrows. And for each trust boundary drawn in the prior steps, map out potential threats to our security goals, perhaps by referring to the STRIDE model. And then select mechanisms that aid us in achieving our security goals to combat threats defined in the STRIDE model. We record these threats to guarantee that they are kept track of in the development lifecycle. So depending on the nature of the API, we may decide to concentrate our efforts on a specific aspect of security. For example, if our API exclusively handles sensitive user data, we need to emphasize security measures that protect this information. On the other hand, if the data isn't sensitive and can be accessed publicly, the same measures aren't required. Through threat modeling, we aim to uncover gaps in our system and in turn bolster our defenses against these threats by utilizing security mechanisms that deal with a particular security need. So let's talk about mechanisms. We require sufficient means to secure our APIs. We have to implement security mechanisms that can be found in any well-developed API. We apply the following mechanisms amongst others, so the first one being encryption. While most mechanisms protect access to the API itself, encryption secures data while it's transmitted over the network between applications. This mechanism fulfills the confidentiality aspect of the triad so that even if the data is intercepted, it'll be useless to unauthorized users without the correct decryption methods. In API design, TLS is used to secure the transfer of data over networks. It aids in integrity and confidentiality. Validation. This is the process through which we verify the data entering the API itself. It's an essential aspect that prevents tampering and information disclosure and should be implemented in every API. It aids in confidentiality. Authentication. Through authentication, we can verify whether an actor is authorized. When implemented correctly, it nullifies the spoofing and elevation of a privilege threat in which users pretend to be somebody they're not. It aids in confidentiality. Authorization. This aspect serves to protect both the identity and the confidentiality of our clients as stated in the CIA triad. This strives to strengthen access control through which threats such as tampering should be rendered obsolete. So let's talk about our security roadmap for this section. Our goal in this section is to understand different techniques that will allow us to design secure APIs. For this purpose, we'll dive deep into the mechanisms that enable us to secure the communication not only between the client and server, but also between the different microservices of a larger service. We'll look into encryption and validation first, including how to safely transmit data between entities and the subsequent validation. We'll delve into cross-origin resource sharing, which is sharing resources between different hosts, its vulnerabilities, and how to overcome them. And it's essential to build knowledge on how systems verify their users and designate permissions on what they're allowed to view and access. Our goal is to describe various protocols and techniques on how authentication and authorization are performed in API designing. And we'll close this section by discussing security models and the scope of APIs. So let's do a quick quiz. First question is, which option isn't a stride threat? We have spoofing, which is, tampering, which is, C, SQL injection, which is an attack, or information disclosure, which is. So I'm going to say the answer is C because SQL injection is an attack. It's not part of the stride acronym. Which security goal isn't part of the CIA triad? So CIA triad is confidentiality, integrity, and availability. So that leaves us with C, accountability. If we decide to forego encryption when transmitting data over the network, which stride threat are we susceptible to? Well, there could be a man-in-the-middle attack, so there could be tampering, or there could be information disclosure, right? People can read that information, so I'm going to say C, both A and B. Thanks so much for watching, bro. It got a little bit dark while I was filming this video, but, I'm glad everything got done. And hopefully you learned something from this video, and if you have any questions, feel free to leave a comment. Also, like and subscribe this video, it would really mean a lot, and I'll see you in the next one.